Have you ever wondered why accurate weather prediction matters so much? It's more than just deciding if you need an umbrella for the day. It plays a pivotal role in a multitude of sectors, from energy production and distribution to agriculture, aviation, and disaster management. Imagine directing energy resources efficiently based on weather forecasts, or farmers planning their crops to the minutest detail, all thanks to precise weather predictions. Picture airlines avoiding turbulence and ensuring smooth flights, or disaster management teams getting a head start on impending calamities. These are not mere possibilities but a reality, all due to the art of predicting weather. The cornerstone of this art, you ask? An equation, the McGinty equation, a tool that has revolutionized weather prediction. It might seem like an enigma wrapped in a conundrum, but don't fret. In the heart of these predictions lies an equation that might seem complicated, but don't worry, we will simplify it for you. Meet the McGinty equation, or as we like to call it, the weather's crystal ball. This illustrious formula isn't just a jumble of symbols and numbers, but rather a key to unlocking the secrets of tomorrow's climate today. Let's start with the first part of the equation, the PSQFT-XT. This term is the solution to the free quantum field theory. It's like the foundation of a house. Everything else is built upon it. This part of the equation describes the behavior of quantum fields, the fundamental building blocks of the universe over time and space. It's the canvas on which the weather patterns are painted. Now, let's move on to the second part of the equation, the fractal-XT-DMQS. This is the fractal potential term. If PSQFT-XT is the canvas, then PSFractal-XT-DMQS is the paint. It's a term that brings color, texture, and depth to the prediction, adding intricate detail that makes the picture whole. It takes into account the self-similar fractal structure of the universe, the repeating patterns that occur at every scale. So together, these two parts of the equation work in harmony. The PSQFT-XT lays down the framework, while the fractal-XT-DMQs fills it in with the intricate details. This collaboration between the two creates a model, a prediction, a glimpse into the future of our weather. But as with all things in life, there's always room for improvement. Enter the modified McGinty equation. Imagine the McGinty equation, now with added superpowers. That's the modified McGinty equation. This version of the equation has a new component, a term represented as scravity, XTG. It's not just a random addition, but a crucial one, since it embodies the perturbative effects of gravity on the quantum field. Think about gravity as a force that has a significant impact on the way things move, how they behave. Now consider its effects on the quantum field. This is what scravity, ETG, captures, with G being a parameter that characterizes the strength of this gravitational force. But why does this matter in weather prediction? Because weather patterns and atmospheric behavior are influenced by gravitational forces. By factoring in these effects, we add another layer of precision to our predictions. But the evolution of the McGinty equation doesn't stop there. It's about to take a leap into the realm of general relativity. General relativity, the brainchild of Albert Einstein, is a theory that describes gravity not as a force, but as a curvature in the fabric of space and time caused by mass and energy. When we incorporate general relativity into the modified McGinty equation, it allows us to account for large-scale gravitational effects that can impact weather patterns. It's as if we're adding another lens to our predictive telescope, enabling us to see the weather with even greater clarity. So what we have now is a supercharged version of the McGinty equation that not only factors in quantum field theory and fractal structures, but also gravity and general relativity. This isn't just a small step forward, but a giant leap in the field of weather prediction. It's like having a more detailed roadmap that can guide us through the complex network of atmospheric conditions and weather patterns. With these modifications, the McGinty equation becomes a more powerful tool for predicting weather. It's a game changer, transforming the way we understand and anticipate the capricious nature of weather. Now, you might be wondering, what does this all have to do with energy? Well, here's where the magic happens. The McGinty equation, in its ability to accurately predict weather patterns, becomes an invaluable tool for energy optimization. Let's delve into this a bit further. As you might know, renewable energy sources like wind and solar power are heavily dependent on weather conditions. Wind turbines need the right wind speeds to generate power, and solar panels need clear skies for optimal sunlight absorption. Therefore, having precise weather predictions can greatly enhance the efficiency of these energy sources. Now imagine you're a manager at a wind farm. If you knew exactly when and how strong the winds would be over the next few days, you could adjust the operations of your wind turbines to maximize power production during peak wind hours and minimize wear and tear during calm periods. This kind of proactive management can significantly increase the lifespan of your equipment while ensuring a steady supply of power to the grid. Similarly, for a solar farm, knowing when and for how long the skies will be clear allows for better planning of energy storage and distribution. During periods of abundant sunshine, excess energy can be stored for later use or sold to the grid. On cloudy days, stored energy can be used to maintain a steady power supply. Moreover, accurate weather predictions are not only useful for optimizing renewable energy sources, but also for managing traditional energy grids. For instance, knowing when a heat wave or a cold snap is coming can help energy companies anticipate increased demand for air conditioning or heating and adjust their power generation accordingly. In the context of our changing climate, where extreme weather events are becoming more frequent, the ability to predict these events and plan accordingly is more important than ever. The McGinty equation, with its quantum and fractal insights, is a game changer for energy optimization. So, the next time you check the weather forecast, remember, it's not just about deciding whether to carry an umbrella, it's about harnessing the power of nature for a sustainable future.